Another indeterminate form that uses L'Hopital is infinity minus infinity, and you're going to change that to the 0 over 0 or infinity over infinity by getting an LCD. That's our main strategy here. So we want to look at the limit as x approaches 0 from the minus 1 over sine x minus 2 over x. And let's see here, x is getting close to 0, but it's less than 0. And so sine x is approaching 0. And remember what sine x, that graph looks like. It starts at 0, goes up to 1, back down to -1, and back up to 0. And then it continues in the other direction. So our x is less than 0, but getting close to 0. So coming into 0 from this direction, you can see that the sine values are negative. So this is positive over negative, so that's going to be minus infinity, minus 2 over x. X is approaching 0, so this is 2 over 0. That is positive 2, and x is less than 0, so that's going to approach negative infinity because it's form number over 0. So it's actually negative infinity minus negative infinity, which is negative infinity plus infinity. And that's the same as infinity minus infinity. So you always got to check that form first. So now we're going to get an LCD to try and change it to one of the main forms. So limit x approaches 0 from the minus side. We've got that 1 over sine x. And let's leave some space here. And then minus 2 over x. So our LCD is going to be the product of those, which is x sine x. So in this piece, the x is missing, so multiply top and bottom by x. And in the 2 over x, the sine x is missing, so we'll multiply by that, top and bottom. So this is now then limit x approaches 0 from the minus. And we've got x here, minus 2 sine x on top. And then over that LCD of x sine x. So now let's go ahead and check the form. So x is approaching 0, so this approaches 0. Sine x approaches 0, so 0 minus 0 on top, which is 0. And on the bottom, both of these are approaching 0. 0 times 0 is 0. So that's 0 over 0. So now we can use L'Hopital. So we'll differentiate top and bottom separate. So limit x goes to 0 from the minus side. Derivative x is 1. Minus 2. Derivative sine x is cosine x. And then in the denominator, we're going to have to do a product rule here. Got an f and a g. So f prime is 1. G is cosine x. And then plus f is x, and then g prime. Oh no, I'm sorry. G is sine x. We did the derivative of the x and got 1, and then times the g is sine x. There we go. And then plus f is x, and then g prime is cosine x. There we go. And so now what do we got? Well, let's see. X is going to 0. Cosine 0 approaches 1. 1 minus 2 times 1, negative 1 on top. And then in the denominator, sine x approaches 0. X approaches 0. Cosine x approaches 1. So this is 0 plus 0 times 1. That's 0. So this is form number over 0. That's going to be plus or minus infinity. So number over 0. And then we need to determine the signs of the top and bottom, positive or negative. So in the numerator, we've got 1 minus 2 cosine. Oh, numerator is approaching negative 1, right? 1 minus 2 times 1. So the top is going to be negative. And then the bottom, sine x here, approaches, as x approaches 0 from the negative, sine x comes to 0 from the negative, so that piece is negative. Our x here is negative, And then what about cosine x? Well, if you sketch the graph of cosine x, starts at 1, down to -1, back up to the top, and then goes the same thing in the other direction. So we're approaching 0 from the negative side. Our cosine function, this is cosine x, and that's sine x. Our cosine function is positive. So that's positive. So negative times positive, this is negative. So negative plus negative, negative on the bottom. This is plus infinity.